Alrighty, we are ready for episode 2. If you haven't seen episode 1, I'll put a link to it in the YouTube card thing. Episode 1 details installing PHP from source. This series, PHP Done the Hard Way, is an attempt at building a PHP installation and a PHP application from the ground up using minimal external libraries. And the reason why we're doing that is sometimes full bells and whistles frameworks are really great, but they can put you in a bubble. So we're trying to break out of that and really explore the language from its kind of roots, I guess you could say. Given that we've got our PHP installation up and running, I've started a local server just using the inbuilt PHP server. If I open my browser and I go to port 8000, localhost 8000, we get a not found, and that's expected because at the moment there's no files in our project. I've created this collab folder in my sites. So PHP sites collab. I plan to work out of this folder to build our kind of sample test application. I'm going to do an introduction video to this whole series, which will kind of give more of a general overview of what I hope to achieve and how everything will fit together and all of those kind of things. And I'll also explain the kind of app that we're going to build. But my hope is to work on this collab app throughout the course of this series and kind of build up to something that will eventually serve as maybe a reference for this series and kind of a reference for doing things the hard way, if you like. So given that this is the first day we've written any code, I'm going to spend a little bit of time just explaining the concepts that I want to use throughout this series. And I want to explain how I'm going to approach the development without a framework, because there are a lot of different directions that we can take this. So I suppose probably the two concepts, or two and a half concepts really, that I'm going to come back to time and time again in this series are MVC, Model View Controller, and interface design by contract / dependency injection. Now, both these topics have been covered really extensively on the internet and probably covered by better people than me. So if you don't have at least a passing knowledge of both of these topics, I would recommend pausing and going and checking out that, because I'm going to be building this application assuming that you've got I don't need you to know those topics intimately. I probably don't myself, but I'm going to assume that you have that base level of knowledge. So if I start to talk about concepts, MVC, interfaces, design by contract, etc., don't worry, but I would say pause the video at that point and just make sure that you've got a vague understanding of what I'm doing, because it'll help you keep context over the course of this video and future videos too. As we get more into the series, hopefully the concepts become familiar with you and you can start to use them in some of your own projects. If you're using Laravel as it stands, you probably are using some of these concepts, but you might not realize it. But that's the whole point of this video. So MVC stands for Model View Controller. At a very high level, the model is kind of your data access. The view is how that data is presented back to the world, and in our case, we're going to keep that as HTML. And the controller is what ties those two abstractions together. Design by contract is an approach to software design that's prevalent in a number of places. Java probably is I would say ubiquitous with this. Maybe I wouldn't say ubiquitous, but I would say it's a very uh, it's the de facto standard for developing Java applications, particularly Java applications that rely on Spring and rely on dependency injection. So we're going to be doing that in our course and in our app today. Now, the really nice thing about PHP these days is it supports all of these kind of things. You can define an interface and you can define a class. So we're going to be using that extensively here. I believe that there are a lot of benefits to designing by contract and using dependency injection. So that's the way I'm going to teach. I'm not saying it's necessarily the right way to do things or the only way to do things. I think for me personally, it works, and a lot of other people it works too. So that's that. We're going to touch on a little bit of PHP being a templated language, but I don't want to spend too much time on that because given the content of this episode, we're really not going to spend much, we're not going to pay too much attention to that fact because we're going straight into a templating system. So with that all said, today, essentially what I want to do is I want to set up the skeleton of my application. I want to build a really, really simple router, and I want to introduce a templating system. And I want to create all of this in a way that makes any component that I just mentioned easy to swap in or swap out. Okay, so let's get started. The first thing I want to do is edit the index file and make sure that my server can see us. Can see the index file rather. So I'm going to say hello from the index. And there we go. So our server's up and running. Our PHP file is getting updated. Now, there's a few different ways to look at routing, but essentially what I want to provide is a way for users to navigate from one page to another to another. So if you were going to look at the simplest possible routing system in PHP, it might look something like this. We will write a single if statement, and I'm going to use get q, and I say if q equals slash echo home. Let's do an if else to get q again, and this time we're going to say about, and I'm going to echo about. Let's end with an else, and we're going to echo not found. All of this is built into PHP. If you don't know what echo does, if you don't know what _get does, pause the video now, go and find those out. There's a lot of documentation on them. I don't see a whole lot of value in covering those things at this point, but just understand that we've written probably the world's most simple router. So let's see how we might use that. Q equals slash. Okay, we've got home. Let's go to about. There's about. And we can also go to somewhere else, and we get a not found. Now, that's pretty lame, but it is a functional router from a certain point of view. I think there's a lot of power in this. I think there's a lot of power to be able to say, stop, no, actually, all I want is a router. Here it is. And that's one of the things that I'm going to be continually drawing on in this course is what is the pragmatic approach? What is the least amount of work that we can possibly do to get something working. And that is a working router in 9 lines of code. Now, there's a couple of things that you might there's a couple of limitations that you might point to straight away. Well, there's a lot of limitations, and let's acknowledge them. Firstly, it's difficult to put HTML in here because we're going to have spaghetti code. Secondly, there's no way of knowing the content type in our router. So are we getting JSON? Are we getting something else? Are we getting an encoded form? Look, we don't know. There's also no HTTP verbs. It just assumes get, but it is rendering different pages. Let's set up some links to our router and a heading. Welcome to Collab. href. We're going to say slash question mark equals slash question mark q equals slash. So this is our home link. Close our a tag. Again, I'm not going to cover any HTML, so if you don't feel comfortable with HTML and you're wondering what I'm doing right now, again, I would pause the video and go and research that. Once you've done that, come back and we'll keep going. So in this case, I want this to be my home link, and let's have a link to our about page. About and not found. Let's go somewhere else. So we know that our not found condition is going to be called. I might also wrap these in a P just so we can more easily tell where the elements on our page are. Alright, so that looks good to me. So let's reload. We've got welcome to Collab. We've got our navigation, and we're at home. We're now at about, and we're now at not found. Now, you might be asking at this point, why have we got this here? What we'll cover in a future episode is actually getting rid of the question mark q equals. So as soon as you do that, you're left with a route that looks like, in the case of about that. Now this won't work, obviously. We'll just get a not found. But the idea is that we'll eventually be changing our URL using Nginx to this format. So you won't see that ugly Q query string parameter there. Okay, so this works. We've built a router, but we've got some limitations as aforementioned. So off the back of this, let's now start to put together our framework for this application. Okay, so now we've got our really simple router, which is kind of lame. Let's build something more sophisticated. Let's start to get the base level plumbing of our application figured out. So the first thing I want to actually have is an application class. And this class will have one method in it, or one function rather, called run. And this function will be run every single time our server is hit. And for now, the only thing I'm interested in doing is calling our controller. Dependent on what our route is. So if I say this controller index, and at this point we're writing against a variable that doesn't exist, and that's okay because it's great for prototyping. So this is how we'd call our index. This is how we'd call our about. And then we could also have a not found in our controller. Okay, that looks pretty good. Now, given that I want to be eventually able to test this, I might not have this underscore get set. So what I'm going to do to make this more testable is I'm actually going to pass that in as a string, and I'm going to pass that in as the path variable. So what we can do with this path variable is transfer the exact same logic we have down here into our application router. So now it will look like controller index, controller about, and controller not found. Fix up the tabbing and remove these echo statements, and we are good. Now you'll notice that I'm still using the get, so let's remove that and change it to path. Same here. And we are currently now divorced from the particular HTTP context, and when it comes eventually time for running our tests, this will become a lot more apparent why we're doing that. Now, given that we've transferred the logic from line 26 up into my application class, I can safely remove this. All we need to do now is call our application, or rather create our application. So I'll do that. I'll call it app, application, and then I'll say app run, and we'll pass in the get parameter of Q. Okay, fantastic. We've got an application. It's completely divorced from any HTML, and it's also completely divorced from any HTTP specific contexts. So if we wanted to run this application class through a unit test, we can do that, and we will do that. Okay, so now we have our router in our application, which talks to our controller, which currently doesn't exist. Let's define our controller. So I'm going to write class controller, and I'm going to define 3 public functions, one for index, one for about, and one for not found. Index, about, and not found. Now, currently our application doesn't know about our controller. One way you might link these two classes together is to instantiate the controller right here. Controller equals new controller, and then at this point we would do something like this, and that would be perfectly valid, and PHP would be happy with us, and away we went. But as soon as we do this, what we're doing is we're actually coupling these two classes together. There's a slightly better way, and this is where dependency injection comes in. Rather than defining the controller as part of the application, I'm going to define a public function called construct. In fact, I don't actually think I can never properly remember the PHP constructor syntax. PHP constructor syntax, constructors and destructors. It's function underscore construct. We don't need the public. Okay, so we've got a constructor. Now what I'm going to actually do here is I'm going to pass in a controller, and then I'm going to set it to a member field of the application class. So I'm going to say this controller equals controller. and we're going to set a private member here called controller. I think I might have, do I have to specify the, yes, I have to specify whether it's private or not. So we have a private member here, controller, that gets passed in. Now, the nice thing about this is that application itself doesn't know where its controller is coming from. Again, when we get to unit testing, this is really, really handy because we might actually want to mock our controller. We might not even have a controller. So in this case, rather than instantiating it into run, which would have made that difficult, we can have these two classes be totally separate for each other. Down here, I'm going to create my controller. Controller equals new controller. And I'm going to pass it in to my application like that. Okay, so we've got our application, we've got our router, we've got our controller coming into our application class, and all we're left to do now is define the actual controller. Before we do that, I'm just going to go through and set up this because it is a member of application. Right, so the next thing I want to do is in controller, I want to start defining my methods. Now, for the moment, I'm going to use the same pattern as I did in the application class with my template management class. But this time I'm going to define the template manager slightly differently. I'm going to use an interface this time. So I'm going to say interface template manager. And then I'm going to have one public function here. Public function. I don't know if I need to specify public on the interface actually. Let's do it for now. Public function render. And then we're going to take in a string here. A string of the template name. So template manager has a single function called render, which takes a string of a template name and doesn't return anything. Again, as we did in application, let's set up a private member, private template manager, and then in our constructor, we'll pass in the template manager in exactly the same way. Function construct, and we'll come down here and we'll say template manager, assign it this template manager equals template manager, like that. Cool. In our index, let's render a template. So I'm going to say this template manager render because that's the method we defined. And for now, I'm just going to hard code the template name to index. I'm going to do the same for about, and I'm going to do the same for not found. About, not found. Okay, that's my controller defined. It expects a template manager. So I'm going to do that right now. Template manager equals new. But I've got a problem now because all I've got is an interface. We don't actually have a concrete implementation. But that's okay because we can create one. Note how the class that knows about the template manager, in this case our controller, doesn't need to have an implementation to be happy. And why that's important will become apparent in just a second. So I'm going to say template manager equals new basic template manager. And then in our controller, we're going to pass in the template manager in exactly the same way we did with the application. Coming back up here, we need to define our basic template manager. Let's do that now. And I'm going to define the one function that I had in the interface. Let's not forget to put let's not forget to put implements. Okay, basic template manager implements template manager. That means that this class must implement this render function, which is exactly what we've done. Now our basic template manager is pretty dumb. All it really does is echoes the template name, which at this point is not very useful, but it's all valid code. So given we've done all of that, let's take it for a spin and see what happens. So I've reloaded this and it's complaining because the type must be of string and I'm giving it a null. So I believe we can use ternary here. Get q or empty string. Let's give that a whirl. Okay, cool. We've gone, don't forget we've still got this ugly route thing. All right, we've got index, about, not found. So I think that's working. Let's just change this to hello from the basic template manager. And then we're going to do a dot template name. So now we should see hello from the basic template manager, which we do. Fantastic. So if I go home, hello from the basic template manager index, about, etc. Okay, fantastic. Let's just quickly review what we've got. We've got our generic template manager interface. We've got a very simple, the world's simplest implementation of that interface, which is our basic template manager. We've got a controller class, which is handling the inputs and deciding what view to render, to display to the user. And we've got our application class, which currently all it is doing is handling our router. And down here, underneath our common theme, which we'll extract out later to a template, we have our dependency context. So this is where we're handling all of our dependency injection. Now don't worry, all of this is going to be cleaned up into much nicer abstractions, but I just wanted to get things running now with something very simple. So that is working nicely. Let's move on to getting an actual template manager running. Okay, so I've gone ahead and installed Smarty using Composer. If you look here, I've now got a Composer JSON, a Composer lock, and a vendor folder. And I think this will be huge. Yeah, that's not too bad. So you can see here, yeah, I've installed the Smarty dependency, and then here are all of its files that it needs. And we're going to use Smarty in our site, our application to render templates. And we're going to set this up as one of our template renderers. So I'm going to grab, I'm just on the Smarty documentation here. I'm going to grab this code as it is, and I'm just going to copy and paste it right into into my program. Now that, have I put it in a funny place? Yes, I have. Let's try that again. Okay, that's better. So let's get rid of the PHP tags. The Smarty library won't be here. It'll be in our vendor folder. So I'm going to put that there, Smarty libs. And it's smarty.class.php, so that's what we want. Let's remove that. And then we're going to call this class our Smarty template manager. Extends Smarty, implements template manager. So it extends the Smarty class that we've required, and it also implements our template manager. Now, they've set up a few folders here which aren't all that appropriate for us. So let's change these. I'm going to use the dir constant, which gives me the current directory. So I'm going to do that, and then I'm going to prepend that string to each one of the these paths, and I'm going to get rid of the prefix here, and I'm going to change that to templates compiled. I want to change that to config singular, and I want to have this in temp cache. So these are the various internal folders that Smarty uses. I believe with the compile and the cache and the maybe not so much the config, but you could probably put these into RAM disks or write them to some other cache, and we might just do that in the future, but for now this is all we need to have. Our application name is collab, and remember that it's implementing our template manager class. So let's make that, let's conform to that implementation by implementing render. And to make life easier, I'm going to put that in. Let me just fix up. I don't think this is quite tabbed correctly. Now it is. Get rid of that. Just tighten this up. Okay. And then here, all we're going to say is this display, which is template name, whoops, not template manager, template name, and then we're going to append a .html because I want all of our templates to be HTML files in our template folder. Let's get rid of that comment, and I generally have requires at the top. That looks pretty good. Now, here's why dependency injection and design by interface is so important. Note how we've changed our renderer completely, but we haven't changed it. We've just implemented a new one. So all I have to do now is, rather than instantiating a new basic template manager, I can instantiate a Smarty template manager. And that is all we have to do to change our entire templating strategy. So let's run this and see if it works. We've turned off our server. So let's turn it back on. Install PHP. This is the disadvantage of not having your PHP file in path. In that we're going to correct this in a future episode and make it a little more convenient. But again, let's just get running now. Install bin php -s localhost 8000. Cool, that's running. Okay, so it's complaining that it can't load the template file about.html, which makes sense because we haven't created it yet. So I'm just gonna do try and do a tmux split here. And we're recording, which I don't want to do. Okay, there we go. Alright, so clear that. Alright, so let's get back to our folder projects. PHP sites, collab. Right, so up above here is where we expect all of our templates. So I'm going to make a directory called templates. Templates, templates. I'm going to make a dir called config. I'm going to make a dir called temp. I'm going to make a dir called temp templates C, and I'm going to do the same with temp cache. Now, I know there's an easier way to recursively make directories. I can't remember it. I never can, so I just make them like this. Okay, that looks good. Let's create our about template. So e templates about.html. Okay, if I can not delete myself, which I'm repeatedly doing, let's create an h2 tag, and let's say hello from the about page. Cool. Hello from the about page. It's no good. Hello from the about page. Alright, let's load this, and there we go. Hello from the about page being rendered by Smarty. If we go home, file index, so let's create that now, templates index.html, and we say, whoops, hello from the index page. Cool. Not found. We've got a not found.html. I don't like that name, so I'm going to change it. I'm going to change it to 404 because that is what's more common. 404, so let's create our templates, 404.html. Some Vim plugin issue I'll have to address at some point. And then we say not found here. Let's test if that works. Fantastic. So let's review what we've got. We've done a lot of work in a very short amount of time. We have an application which contains our router, which is totally divorced from the current HTTP context, so we can do testing without having to do a whole lot of complex mocking if we don't want to. We have a controller, which at this point all it does is call into our template manager, but this is where we will pull data from our data layer. This is where we will do any other HTTP related things like responding to various HTTP verbs, etc., etc. We have our basic template manager, which got us running, which doesn't actually do anything other than just echo out the current template name. And most significantly, we've got our Smarty template manager, which implements the exact same interface as our basic template manager, but it gives us the entire power of Smarty in our application in a way our application understands. And of course, we've got our just template manager interface that defines the one method render.